Welcome back. So in this video we're going to talk about energy transfer and how work can accomplish this. So energy transfer happens when a system's energy changes because of outside influences, specifically with our environment. So we have our system, our environment, and an interaction with the environment is going to cause this energy transfer to happen. We're going to change the total energy of our system. In the last video we said that delta E of our system, delta energy of our system, is always equal to 0 when it's not interacting with an outside system, when it's not interacting with the environment. But once I start interacting with the environment, delta E sys is not equal to 0. So I can talk about mechanical energy, energy transfer. We're going to talk about that in terms of work. Define that as work. And when we say mechanical, what we're actually saying is that this is a physical pushing and pulling of objects. It's changing its bulk speed. So this is a macroscopic effect, right? We're going to say push, pull. In parentheses, we'll say physical. When we're talking about thermal energy transfer, we're going to talk about that in terms of heat, right? We're heating or cooling something. We're transferring this heat energy, this thermal energy. So if I put something in contact, let's say, if I take my coffee mug here, right, and I take a small, I don't know, something small, like a dice, a little die here, I could pop it in here. Thinking about this as my only part of the system, I'm now going to have it interact with the environment of the coffee mug. This is going to change its thermal energy. I'm going to apply heat to it. And so these are all types of, wrong pen. These are all types of energy transfers. We're only really going to focus on this work part. We're not going to focus on heat in this course, unfortunately. That's more thermodynamics and an interesting study in and of itself, but not the focus of this class. So work starts to quantify how much the outside interactions or forces change a system's mechanical energy. I know we said that we would really kind of start to stay away from forces moving to energy, but we're going to see that force is actually the thing that starts to mediate work. These are all interconnected, and while we can kind of talk about it in terms of forces or in energy, really it's talking about it it's talking about the same thing. So the last thing I want to kind of just stand on here before we really focus in on work and define that a little bit further is that maybe a more complete way of talking about our system of our energy of our system is that the change of the energy of the system is equal to the work done externally, or the work done by the environment, the work done by the external environment. And so the book likes to, and I do too, but I'm pointing this out in case you're following along with the book. The book likes to call this the energy principle. So if a homework problem talks about it, or if you're reading along in the book, we have the change of mechanical energy in a system. Normally we're just going to say mechanical energy is big E is equal to the external work done on the system. Right? Not by the system, on the system. All right? So that is energy transfer in a nutshell. I'll see you back here in just a bit. Talk about work.